strategy capability. So today's session is designed around an end-to-end workflow mindset, understanding the business problems, working with the real-world data, and building and evaluating the AI models and deploying responsibility into productions. And most importantly, we are just creating a measurable product value. So this masterclass is going to reflect the Get Interest Academy's commitment, supported by frameworks aligned with SSG. All right, so to deliver some industry relevant, practical learning that professionals can apply immediately into their roles. So whether you're a product manager or product engineers, analyst, or business leader, my hope is that you leave today with a clear roadmap for AI driven innovations and practical tools for implementation and the confidence to lead AI initiatives into your organization. So let's make the session interactive. You can ask questions, you can challenge some ideas, and you can share your experiences. So without further ado, thank you so much for joining us again. I wish you an insightful and impactful learning experience. Right. So my name is Renu. I'm a senior data scientist with over 14 plus years of experience, and I have trained more than 500 corporate professionals. But here is what matters to you. I have spent the last decade bridging the gap between a product strategy and MLOps. I have seen that what works in production and what stays stuck in Jupyter Notebook. So this masterclass is a compressed version of a flagship 40 hours course, which is the SSG funded course and also a HRD Corp accredited, right? By end of today, you will understand whether this is the right investment for your career. And I'll show you how this training for as little like $1,000 after government subsidies, right? Let's quickly jump onto a learning roadmap. So this provides an overview of the key steps in building successful machine learning system. So the first step is architecture, understanding how to get data to work together and flow through the data supply chain, right? Next is preparation, ensuring the data quality through a rigorous quality gate process. And third phase is about development. We focuses on the differences between training models and deploying them for real world inference, right? And reliability is a critical to address the silent killer of model drift over time. And finally, deployment. So deployment requires automation and MLOps to operate your production ML system efficiently. Now I know like what you're thinking. That sounds like a lot, and you're right. This is complex. So that's exactly why most projects fail. But here is the good news: by understanding the complete system, not just the code, you will be ahead of 87% of your peers. So we are going to walk through the 5 critical phases of the AI development life cycle from architecture all the way to till deployment, right? Right. So look at the statistics. 87% of data science projects never make it to production. So think about that for a second. That means if you start 10 AI projects, only 1 or 2 will actually deliver that values to the user. The rest stuck in development hell. So see this iceberg on the left side. So the model code. So the part everyone obsesses over is just the tip of the iceberg. So everything below the waterline. So that's the infrastructure, data pipelines, monitoring, deployment, operations. So that's what it kills the projects. So the reason their focus is only on code and they forget about the system. So here the challenge between we need to focus on code versus focus on systems. So the quick poll in the chat, how many of you have worked on projects that never made it to production? You can type S if you have. Yes. Have you ever worked on any AI projects before? Yes, no.
Anyone, you can open
Yeah.
your mic or any.
So if you feel shy, you can
So
type
you
it in the
can
chat.
share your thoughts also in Zoom chat. Thank you.
Right, I can see in the chat, did not work on AI projects at all. Right, never mind. So here you're not alone here. This is the industry norm. Even if you see a lot of challenges that never made it to productions, but it doesn't have to be your norm, right? So in our full 40 hours course, we will spend building the muscle memory to think in systems, not just scripts. So today I'll give you the framework. If you want the depth, stick around to the end, right? So before we dive into the technical details, let's zoom out. AI doesn't exist in a vacuum, right? It exists within a product life cycle. So right from ideation, like what problem are we solving, right? And feasibility. Can AI actually solve this? And next is prototype. Does our approach works on sample data, right? And production. Can we scale this to real users? And finally, can we maintain and improve this over time? So most data scientists are trying for phase three, like building prototypes. But product success, it requires mastering all five phases from phase one to till phase five, from ideation, feasibility, prototyping, production, and last, it's a scaling process. How do we going to maintain and how we are going to improve this over the time, right? So let's start at the beginning. How do you even get your data ready for AI, right? Right. All right, let's talk about the first major hurdle, data interoperability. Look at this image. So this is what your data landscape looks like in most organizations you have got. One is like customer data in a CRM. It could be a structured data or any relational DB, and it might be an IoT sensor data. It could be a time series data or unstructured. Of course, we have an application logs, we have the user behavior, it could be NoSQL or JSON file, right? So the challenge here, these systems like JSON file and or unstructured, semi-structured or unstructured or structured data, whatever it could be the file format, these systems don't talk to each other, right? We'll be storing our customer data in SQL, whereas the transaction data we might be storing in JSON file. Generally, they don't talk to each other. So the solution for that problem is ETL pipelines. So we'll be extracting, transforming the data, and loading that into a specific form, whether it could be the on-premises or the cloud environment, right? So imagine you are going to build a recommendation engine for an e-commerce platform. So you need a purchase history, the browsing behavior, and the product inventory. And of course, we require some user demographics from 4 different sources. How do you bring this together? How do you bring all these together, right? So you build a data pipeline that extracts from each source, transform it into a common format, and you have to load that into an unified warehouse, right? So in our course, like you will be building 3 complete ETL pipelines from the scratch using Python and SQL, right? So of course you will have a portfolio piece you can show in interviews, like we'll be building a complete end-to-end production application, right? Okay, now the next step is once you have extracted your data, where do you put in? The next question, where do you put in? If your data has clear relationship and you need some asset guarantees like financial transaction, so that uses SQL, right? If your data is constantly evolving and you need horizontal scaling like social media feeds, something, then we use NoSQL, right? So the common mistake, this is a simple rule. If you have a clear relation, we can store it in SQL. If your data is constantly evolving, we can store it in NoSQL. That is, it's completely a flexible one, NoSQL. It's not going to be a rigid structure. Okay, the common mistake here, I see teams chose NoSQL because it sounds modern. Then they struggle with a data integrity issue, or they choose SQL and hitting performance wall at scale. So the key here, match your storage to use your use case, not just the hype cycle or hype scale, right? So in our actual course, like we'll be doing side by side comparisons with real data sets. You will implement the same AI model using PostgreSQL and MongoDB. Then the benchmark performance and also the cost might vary from one model to the other one, right? And also you will feel the complete trade-off, not just reading about them. Okay, let's talk about this in detail in the upcoming slide. Right. So now let's talk about the data formats. Now we know where to save, like we have SQL and NoSQL, depends on the data characteristics of your data. You'll be saving either you'll be opting SQL or NoSQL. Now let's talk about data formats, where you can save thousands in Cloudcast. So I recently worked with a client training data in JSON. So the model training time is 6 hours, right? 6 hours to train JSON data. Then we converted into a Parquet file. The new training time is literally 45 minutes. Same data, same model, but it's a different format. Okay. So quick show of hands in chat. Who has used Parquet file before? Type P for S or N for no. Yes. So who has used Parquet file? Okay, I can see in the chat. No, right. Yes, most people haven't, but this is exactly the kind of a production optimization. So if you want to separate from junior data scientists from senior ML engineers, probably they'll be using either CSV file or other files. But if you convert that into a Parquet, your optimization is quite faster and you can see the efficient performance if you use a Parquet file, right? So this is my favorite slide because it is the most honest representation of a data preparation. Rule number one, garbage in, garbage out. So no matter how sophisticated your model is, if your input data is garbage, your output will be a garbage. So I worked with a retail client building demand forecasting. So the model kept predicting wrong. Then we found because of negative quantities, meaning it returns coded wrong, and dates in the future, data entry error, and prices of zero. So free samples coded incorrectly. So these were not bugs in the model, they were bugs in the data. So it's not with the model, right? Let's understand the process of EDA. So summary statistics, what are the things we can see? For instance, if you want to calculate the complete structure of your data frame, like if you want to understand the statistics of your data frame, then we'll be taking a mean, median, min, max to understand the skewness of your data, whether your data is completely scattered within a given environment, in the given 2D spaces. If it is skewed, right skewed or left skewed, your model might be completely biased towards the largest number. To understand the structure of your data, we need the summary statistics, right? And in order to understand any weird spikes, then we'll be using distribution plots. And to understand how much data is null, is present in your data, then we'll be using missing value analysis, right? And to find the correlation between one feature to other feature, we'll do a correlation check to find the relationship between two features. Okay, sometimes your data is completely deviates from the action score. For instance, if you consider age column, you don't see any values greater than 150 or something, or less than, anything should be less than 100 is acceptable. If it goes beyond 110 or 120, then we have to suspect. So it is completely deviating from the actual value, right? So that is beyond some standard deviation score. Then we have to detect an outlier. So these stories, like to understand all the EDA process, generally we need to spend at least 8 hours in the course just on data preparation, right? So this is the quality gate. Okay, let's talk about something that doesn't get enough attention called sampling strategy, right? If you are building a credit score, imagine if you're going to build a credit scoring model and it uses a random strategy, okay, or random sampling strategy. You might end up with only 2% representation of minority groups. Okay, but if those 2% have systematically different behavior due to historical discrimination or it is not a merit, then your model will be worse for them. Okay, so we'll be using a stratified sampling. It ensures minority groups are represented at higher percentage in training. So your model performs well for them too. So that's the key difference between sample strategy and stratified sampling. So this is not just about being nice. It strictly follows some guidelines. Specifically, for instance, if you take a financial institution, they follow MEA's guidelines, right? In order to monitor any algorithmic bias in the model. Okay, biased AI is completely illegal, right? So we dedicate an entire module to sampling your strategies and fairness in the metrics. So we have to implement a stratified sampling. We need to test for disparate impact, and we need to learn a lot of regulatory compliance or documentation, right? So that's the key difference between, because random sampling is quite fast and efficient, but it risks underrepresenting minority groups. Whereas, on the other hand, if you take a stratified sampling, it ensures that all user groups are represented equally. It provides a more balanced and representative sample. So that's the key difference between random sampling and stratified sampling. And the next process is feature engineering. So it is again a process of translating human reality into a machine readable vectors. So it is like, to put it simply, it's like a bridge between the real world and the mathematical models we use in machine learning. I'll give you a couple of examples to illustrate the concept. Okay, so we have a lot of techniques to represent or to convert non-numeric into numeric. One is one-hot encoding. We are representing a categorical variable like Monday, Tuesday, Wednesday. It's just that converting into a vector of zeros and ones. We call it as one-hot encoding. And we have another technique called text-to-word vectors, translating text descriptions into a numerical vectors. So that captures all the semantics. And then we teach some practical techniques for feature engineering, including encoding categorical variables in different ways, transforming numerical features like log scaling or standardization. And also we are extracting some temporal features like days, month, or year. And also we are combining some features to create some interaction effects. So feature engineering is just like an art and a science. It takes practice to get right. Right, so that's why our complete course will give you the guided practice to really master these techniques. Okay, so this is the heart of machine learning, translating human reality into machine vectors, right? So your model doesn't understand Monday, it understands number, right? So the solution for that is one hot encoding. Got it? So feature engineering, as I said earlier, it's an art backed by science. It takes practice, and that's exactly what we give in our actual 8 hours of a guided practice in our regular course. Right. Now let's get into a fun part of building a model. But first, understand this fundamental distinction between training versus inference. So like studying in a library for months is a training. On the other hand, if you take inference, like taking orders in a busy restaurant. So training is the process of learning some pattern from the data, which is computationally intensive and we have done in batches. It's like studying in a library for months to learn the material. On the other hand, inference is the process of applying those learned patterns to new data in real time. So which needs to be fast and low cost. It is like taking orders in a busy restaurant, as I mentioned, where speed is critical, right? So most of a production system's activity is inference. It's not about training. If inference is slow, the product becomes unusable. Okay. For example, in a fraud detection system, training may take 6 hours on a GPU, on a graphics processing unit, to analyze 10 million transactions, right? But inference needs to happen in 100 milliseconds to decide if a purchase is fraudulent or not, right? If it takes 6 hours to identify the fraudulent case, then there is no point. It's completely unusable, right? So that's the key difference between the training phase and the inference phase. So you want to train your model and you have to serve that model. So where do you do this? The next question, where do you do this? So the cloud stack provides a managed platform that addresses common pain points of building on laptops. So we have a scalable GPU. Easily we can spin up our powerful GPU instances as needed and we can shut them down when finished, right? So cloud platform provides some enterprise grade security and also the compliance certification out of the box. And also we can easily track the version control. We can easily track and roll back every experiment. So this will avoid the hassle of managing your code and data locally. So data scientists often waste weeks of setting up the TensorFlow on their laptops. They are struggling with some driver issue like CUDA drivers. Then they'll be using some managed platforms instead. So all labs in our course will be running this on a cloud environment, Google Colab, which provides free GPU access with zero setup in the browser, right? So why do we build on laptops? So why do we, why we don't build on laptops? One, to get a scalable GPU. The other is security compliance. And thirdly, we can track every experiment, the version control. So we can roll back easily. So I see data scientists spending weeks to setting up all these things, struggling with some drivers. So stop using that. You can run or you can deploy this into any of the AWS SageMaker or same platform as Netflix, Airbnb, and Lyft users, right? And the next concept is API. So this is a key part of
Good
our.
evening, sir.
Yeah, Mr. Prince. Right. So once your model is trained, how do other systems talk to it? Right? If you hard code the model into your application, every model update requires a new app download. So your app is huge, your model weights might be a gigabytes, or you can't do A/B test at different models, right? Instead, use an API. API makes the request, API returns the predictions, your update models without changing the app, right? And also, like this part is all about building a fast API service. So you will learn here the RESTful design, like request validation, response catching, the error handling, and all kind of authentications will be covered in D4. So the API is like a bridge between your AI brain and the user experiences, right? Right. Okay, this is the main part is all about drift. So drift is a silent killer for AI models. So we just wanted to understand the relationship between input and output. So it can change over time and also it causes some model performance to degrade. This is a critical challenge for deploying AI in the real world. So model needs to be able to adapt to changing conditions and the data distributions, right? So here the drift occurs when even if there is a shift in the data, the concept drift might occur. So the model prediction no longer matches with your true output. So this can happen for many reasons. Like if there is changes in the user behavior or if changes in the environment or changes in the data collection process, there are so many reasons that the drift might occur. So we need to detect it and we need to mitigate those drift is essential. So mitigating drift is essential for maintaining your model reliability and also to in order to improve your model performance over time, detecting and mitigating drift plays a major role, right? So this is like a silent killer for AI model. So this part is also covered in our actual course, like how to detect the drift and how to mitigate those risks before we put into an end, right? And the final phase is all about monitoring. Though you have done with your application, if you are satisfied with the model performance, we can deploy that in a production environment. It is not about like it's a one-time application. Like we need to continuously monitor this process. So monitoring the health and performance of your machine learning model is crucial to ensure they are delivering the expected results. Okay. So the key things we want to monitor are one is speed. We call it as service latency. So we want predictions to return in under 100 milliseconds. Okay, and the next is data distribution. We need to ensure the incoming data features matches the training data. So we might have done a lot of feature scaling, feature engineering, and we might have done a lot of EDA. But when you receive certain things from the user, like a new input or unseen data, we need to do the same step. Whatever we have applied for the training, we need to apply the same technique to our new data as well. So if you didn't apply those things, then we will end up with a bad accuracy score, right? So we always ensure that the incoming data features matches the training data using techniques like histogram, or we have a lot of bar charts or KL divergence. We can use these techniques to ensure the distribution of the data, right? And finally, we need to predict the accuracy, right? We should track a real-time accuracy, and we need to alert when it drops below the accepted level, right? So by closely monitoring these core metrics like service latency, data distribution, and prediction accuracy, we can quickly identify and address any issues with our model, ensuring they continue to perform well for our users. So drift is scary. So how do you catch it before it kills your product? So that plays a major role. It's like we need to do these steps, these three steps, right? So like in our actual course, like we set up a dashboard and we can see the drift. We will look for the score. If it is less than the below range, the notification, the action gets triggered and it will notify through email or through a number or through, I mean, we can give the way how do you want to communicate, right? So here we will be building your own monitoring dashboard to track all these three matrices. Okay, then you can deploy that into a different tool like HeroQ with a live URL for uh, the recruiters. And finally, MLOps. So MLOps applies the DevOps principle to a machine learning, meaning it's automating the end-to-end process. So data scientist pushes their code, pushes the code changes to GitHub, triggering some automated tests to check for data schema violations, right? And also the cloud platform. So how it is automatically training the models, right? And if it's successful, you can deploy the new model to production to replace the old one. So this streamlines the machine learning lifecycle. It reduces the manual effort and also it increases the reliability, and also it will speed up the like the model updates. So MLOps is completely applying the DevOps principle to a machine learning model. So these are the workflow. Code pushes the code to GitHub. We need to check the test for data schema violation, and we need to automatically train your models using cloud platform. If you are successful or if you feel satisfied with that, the new model replaces old in production. So the magic here, from code commit to till production with zero manual steps. Okay. So companies with mature MLOps, they iterate 10 times faster. So that is how the Netflix test hundreds of algorithms. So that's how the Spotify personalizes for 500 million users. Okay. So we need to build a complete CI/CD pipeline using GitHub Actions, using Docker and AWS SageMaker, right? So all these things will get updated with one Git push, right? Okay, and finally, this is one of the powerful tool called Docker that enables containerization, meaning it's like a packaging of software into a standard units called containers. So the key benefit of Docker is portability. It allows applications to run consistently across a different computing environments, meaning we develop the applications on our own laptop, right? And we need to deploy that into a production server, right? So to make it happen from developer's laptop to production server, we need a Docker. So Docker package all the softwares into standard units called container. So this will run consistently across different computing environments, meaning this eliminates the common problem of it works on my machine, because the same Docker container will run the same way everywhere, right? So meaning this containerization with Docker will provide you a reliable, consistent way to package your applications. right? Making it a valuable tool for modern software development and deployment. Like the graduates can deploy their sentiment model using Docker. If the client wanted to run it on AWS, or they wanted to run it on their on premises, or if they wanted to run it on a Raspberry Pi, the same Docker container worked everywhere. So that is the added advantages of using this a Docker. I'll show you one case study, like what we generally we'll be covering this case study uh, to show like how an e-commerce platform can use a predictive analytics to reduce the customer churn. The scenario is that the platform wants to stop the users from canceling their subscription, right? So the goal is to to predict the cancellation 30 days in advance, so the platform can take action to retain those customers. So what is the key metric here? So they wanted to be very precise on focus on a precision. They don't want to give discounts to the happy users who weren't going to cancel anyway, right? So the challenge is building an accurate churn predictor model that can identify the right customers to target with retention efforts. So probably they might have purchased every month, every 30 days they used to purchase certain things. If the model predicts that regular customer, there is no point in giving discounts to the happy users, right? So the model has to be accurate to predict the churn model. So that can identify the right customer to target with some retention efforts. So let's put everything together with the real world. This is the e-commerce platform. Wants to stop subscription cancellation. Goal. What is the goal here? They need to predict the churn 30 days in advance. So before I walk through the solution, maybe you can type it in the chat. What features do you think predict churn? Anyone? So what features plays a major role to predict the churn? All right. So I'll give you a walkthrough of the 5 phases of the churn prediction model, the complete development phase. The first phase is ETL. We extract the data from MongoDB and we load it into PostgreSQL database. So this is the ETL phase. Extracting data from a NoSQL and loading it into a SQL database. So in the preparation phase, we'll be doing a stratified sample phase. We ensure the training data includes a representative sample of the churned user, despite the low overall churn rate. And in the development phase, we'll be training with some model. Here I have given XGBoost. Maybe you can try with any model on a cloud phase. We train a model on the cloud environment using a lot of engineering features to achieve 78% precision in predicting churns, right? And we'll be monitoring for seasonal trends, seasonality drift phase. So we account for differences in churn pattern, right? That is like seasons by using a separate model and monitoring for drift. So we need to look for the drift, right? And on the operation side, we will be retraining this model, auto retrain. Weekly on a new churn data phase, we automatically retrain the model if new churn data is available using a lot of tests like A/B test, model, and we are promoting this into a production to show a lift of over 2%. So these are the complete 5 phases of the churn prediction model, right from architecture like ETL transformation, then we'll be preparing the data, developing the model, and we are testing this to monitor your seasonality drift. And then finally, we are doing operation, right? So auto retrain weekly on a new churn data phase. So we automatically retrain the model if new, as and when a new data comes, we need to retrain the model in order to mitigate the drift problem. Right. So the next is before we talk the next steps, the common questions. Do I need to be a data scientist? Do I need to be a data scientist for this? No. But you need to understand the full stack. There are four key roles. A data engineer build the pipelines, like extracting the data from SQL, doing a lot of ETL stuff. When you talk about data scientists, they build the math, the ML algorithms, right? Whereas ML engineers builds a complete factory, like till Docker, and they will be deploying in a cloud environment. And we have the fourth key role is product manager. They will define why and what is the value of it. So these are separate roles in most companies, but the best professionals understand all four perspectives. Like maybe you can question yourself, where do you fit here? Technical but not coding heavy, PM mindset plus technical depth. If it is a software engineer, they have to learn ML. They need to understand the data to become an ML engineer. If it is a data analyst, they have to level up to data analyst can level up to data scientist or data engineer, right? And data scientists, they can add some deployment skills for full stack. So our 40 hours bootcamp covers all four perspectives. Like they might be aware like what is possible. Data scientists know how to collaborate, and also engineers can translate all the business into a technical part. So you don't need to be an expert in all four, but speak the language. That's what we teach, right? And let us try to understand the key differences. A quick note on where AI is heading. I know you're thinking about ChatGPT or Claude or Gemini or Copilot. Let's understand the key differences here. When you talk about predictive AI classifies the existing data. They focuses on to focus of today's Gen AI, meaning it creates a new data, the new frontier, right? So predictive AI is classifying the existing data. Mainly they focus on today. On the other hand, if you take Gen AI, it creates a new data. So what is the intersection between these two? It's a sweet spot. Using ChatGPT API to clean your messy customer reviews, then you feed it into your churn model. While we focus on, predictive AI, we include Gen AI integration. So you will learn to call Open AI API, and also we can use LLM for feature extraction, and then we can combine the traditional ML with a foundational models. So here Gen AI is a flashy term, but predictive AI pays the bill. Okay. The main point here, you need to master the fundamentals first. Then you can add Gen AI as a tool. So we cannot completely rely on Gen AI. If you are not, clear in the fundamental part, then generally the LLMs will hallucinate, right? So we need to understand what is the next step, what are the key features we need to add in, what is feature engineering. We need to be, at least we should have a fundamental knowledge of ML techniques, statistics, linear algebra, and a little bit about the ML parts. So master the fundamental first, then you can add Gen AI as one of the tool at the end, right? It is a flashy term. So this particular slide outlines the build versus a strategy, build versus buy strategy. The key is to here focus on in-house development effort on the code. Okay, so the strategy question here, when should you use build and when should you buy? So you can take buy as APIs. It's a non-code. So commodity features like OCR or any translations, low control needed, right? So you'll be buying an API. When you talk about a build, it's a custom based one. It's a core IP, like a proprietary features like recommendation, niche predictions. It has a high control. It is not like a low control. It's high control, low margin cost at scale. So the decision framework, you need to decide whether this is the competitive differentiator, build it. Is this hygiene? Then buy it. So do I have a unique data pre-trained model? Don't, right? So we have to build it from the scratch. So e-commerce company, generally we teach you to build because that's where the value is. Where interesting jobs are, once you can build, you can intelligently evaluate like what to buy and what not to buy, right? So we teach you from the scratch, right from ETL, preparing your data, doing a lot of feature engineering, and we'll be comparing all the packages and we'll be deploying that in a production environment. So right from we will be incorporating all 5 phases. So finally, this particular slides provides you the overview of the key topics covered in the training. So we'll start by discussing how to architect data pipelines using ETL, extract, transform, load techniques. This involves integrating data from heterogeneous sources, working with SQL, NoSQL databases, and we'll be converting that into an unified golden parquet record. So that is the suitable file format for building an ML model. Next, we will cover validating the data quality through EDA, through exploratory data analysis, and we'll be using some stratified sampling techniques. So this helps ensure the data is accurate, complete, and ethically sound. We will then look at a monitoring model for data drift. So usually we'll be using a lot of statistical methods. We are not going to build any functions on our end. Rather, we'll be importing the classes, functions, methods using some framework. So that particular dashboard will help us to detect the distribution shift over time. Finally, we'll be exploring like the automation of the ML lifecycle with MLOps practices. So this includes CI/CD pipeline, Docker containerization, and continuous retraining of your model, right? So if you got stuck with me with this whole time, I understand this was a lot of information. If you are a beginner to this was a lot of information. 1 hour is just scratching the surface. So, this definitely brings you guys to the next level. So this is not just about code or something. It's about a complete system I'm talking about. So taking AI from notebook to productions that we'll be covering in the 40 hours course. So that's a big difference. That's a big difference between like a portfolio project and a promotion, right? I'm not talking about just about the code. So I'm talking about the entire system, right from fetching to till deployment, and we need to do a lot of CI/CD pipelines at the end, right? So that's it about the complete 5 phases of applied AI. So 3 big differences here, right? So thank you for your time today. Whether you join or not, I hope you have a clear picture of a production AI system. Don't let the 87% failure rate be your story. Learn the systems, master the workflow, and build the AI that ships. Right? Any questions before we wind up this? Any questions from anyone? I hope today's session helps you build the AI that truly ships to production. Yes. So many professionals attend master classes and they get an idea, but transformation happens only when you practice with guidance, right? So in Guarantor Academies, this applied AI program, we mentor you step by step from business problem to till deployment. This is completely aligned with SSG and HRD Corp Malaysia framework. If you'd like to move from learning to implementation, we would love to support you. Any questions before we wind up? Can I get a quick thumbs up? Hope you have gained some useful knowledge from this masterclass. Can I get a quick thumbs up from everyone? Right. Right. So thank you so
Do you
much for
have
your
any
time.
questions? Yeah.
Yeah,
So
please take
yes,
it.
ma'am, I think okay, so before we wrap up, I would like to request everyone to kindly open your cameras. Let's have a quick group photo for the record. We'd really appreciate if you could turn your cameras on for a moment so we can